Now see next question, question number 4. Reduce the equation r bar dot 3i plus 4j plus 12k equals to 78 to normal form, and hence find number 1 the length of perpendicular from the origin to the plane, that means value of small p. Number 2 direction cosines of the normal. We have to find here direction cosines, that means the value of L, M, N. So first we reduce the given equation to normal form. So in solution, we know that the normal form of equation of plane is r bar dot n cap is equal to p, where n cap is the unit vector along normal, and p is the length of perpendicular from the origin to the plane. That means we have to reduce this given equation in the form of r bar dot n bar equals to p. So in this equation, given equation, we write here n bar is equals to, this value is value of n bar, so we write n bar equals to 3i plus 4j plus 12k. So from this we first find the magnitude of this normal. Therefore n bar is equal to, so 3 square is 9, 4 square is 16, 12 square is 144. So we write this as square root of 169. Now square root of 169, if we calculate, we get value equals to 13. Now given equation we represent as equation number 1, r bar dot 3i plus 4j plus 12k is equal to 78. Now we require the equation in this form, r bar dot n cap equals to p. So when we divide any vector by its magnitude, then we get unit vector along that vector. So we divide both sides by this magnitude of n bar, that is by 13. So we write here divide by 13, we get r bar dot 3i plus 4j plus 12k upon 13 is equal to 78 by 13. So after dividing by 13 to right hand side, we get here value 6. Now when we transfer, or we can write this as r bar dot 3i plus 4j plus 12k upon 13. This is value of normal vector. So we compare this with r bar dot n cap equals to p. So from that we get the length of perpendicular from the origin to the plane. So we write here compare with r bar dot n cap is equals to p. Therefore p is equals to 6. This is solution of first sub question. Then we have to find the direction cosines of the normal. Now this is unit vector. So from this we write n cap as n cap is equals to 3i plus 4j plus 12k upon 13. Now we separate the base. So we get 3 by 13 I plus 4 by 13 j plus 12 by 13 k. Now This is unit vector, and the coefficient of I, j, k are the direction cosines. So the direction cosines we get. Therefore direction cosine are 3 by 13, 4 by 13 and 12 by 13. So in this way we calculate the length of perpendicular, that is value of P, and direction cosines of the normal. Now say question number 5. Find the vector equation of the plane passing through the point having position vector I plus j plus k and perpendicular to the vector 4i plus 5j plus 6k. So if you observe this problem based on first theorem, the vector equation of plane passing through the point A of A bar and perpendicular to the vector n bar. So we write here in solution the vector equation of plane passing through the point A of A bar and perpendicular to the vector n bar is r bar dot n bar is equal to a bar dot n bar. So here position vector of a point is given, that means value of a bar is given. So a bar equals to I plus j plus k, and perpendicular vector, that is value of n bar. So n bar is equals to 4i plus 5j plus 6k. Now first we find the RHS, that is value of a bar dot n bar. Therefore a bar dot n bar is equals to, we write value of I, value of vector A as I plus j plus k dot value of vector n as 4i plus 5j plus 6k. Now multiply these two. So I dot I is 1, I dot j is 0, I dot k is 0. So we write I dot I 1. So we get 4 into 1. So we write 4. Then j dot j is 1. So coefficient of j is 1. So 1 into 5 we get 5. So 4 plus 5 plus k into k, that is k dot k is 1. So coefficient of k is 1. 1 into 6 we get 6. That is equals to 15. So this is value of a bar dot n bar, and here r bar dot n bar. So we substitute all the values. Therefore r bar dot n bar is equals to a bar dot n bar gives r bar dot n bar is 4i plus 5j plus 6k is equals to a bar dot n bar is 15. Therefore this is required equation of plane passing through I plus j plus k and perpendicular to vector 4i plus 5j plus 6k. Now see next question, question number 6. Find the Cartesian equation of the plane passing through A of minus 1, 2, 3, the direction ratio of whose normal are 0 to 5. So this question based on Cartesian equation of a plane passing through a point A of x1, y1, z1 and the direction ratios of normal A, B, C. So we write in solution the Cartesian equation of plane, the Cartesian equation of the plane passing through x1, y1, z1, the direction ratios the direction ratios of whose normal are A, B, C is A in bracket x minus x1 plus B in bracket y minus y1 plus C in bracket z minus z1 is equal to 0. That means just we have to substitute the value of coordinate x1, y1, z1 and the direction ratios A, B, C. So from this we find the Cartesian equation of the plane. So here x1 is equals to minus 1, y1 is equals to 2, z1 is equals to 3 and the direction ratio ABC, A is equals to 0, B is equals to 2, C is equals to 5. So we write here, therefore required Cartesian equation of plane is, now substitute the values, here A is 0, so we write a 0 in bracket, x minus x1, x1 is minus 1, so minus minus get plus 1, plus b, b is 2, y minus y1, y1 is 2, so y minus 2 plus c is 5, 5 in bracket, z minus z1, z1 is 3 is equals to 0. Now when we multiply by 0 we get 0, so first term is 0, here we have to multiply by 2, 2y minus 4 plus 5z minus 15 is equals to 0. Therefore we write 2y plus 5z is minus 4 minus 15, so we get minus 19 equals to 0. This is the required equation of plane. Now see next example. The Cartesian equation of the plane passing through A of 7, 8, 6 and parallel to the xy plane. Now this problem is same as previous example. In previous example the direction ratios of normal is given, but here instead of direction ratios of the normal one condition is given. That condition is the Cartesian equation of the plane passing through A of 7, 8, 6 and parallel to the xy plane. That means we have to find the vector Cartesian equation of the plane parallel to this plane. Now see here, we draw here a rough sketch. Here this plane is on this xy plane. So this xy plane is perpendicular to this z axis. That means this z axis is also perpendicular to this required plane. So from the direction ratios of the z axis we can find the direction ratios of the normal to the required plane. So first we write here the Cartesian equation of the plane passing through x1, y1, z1. The direction ratio of whose normal are ABC is A in bracket x minus x1 plus B in bracket y minus y1 plus C in bracket z minus z1 is equals to 0. Now here we have to find the value of ABC because coordinate of point is given, that means value of x1, y1, z1 is given. Now this z axis is the normal to required plane. Z axis is normal to a required plane. Therefore direction ratios of z axis is 0, 0, 1. That means the direction ratio of normal is 0, 0, 1. So we write here x1 is equals to 7, y1 is equals to 8, z1 equals to 6 and A is equals to 0, B is equals to 0, C equals to 1. Therefore a required Cartesian equation of plane, Cartesian equation of plane is, we substitute the value of a as 0. So 0 in bracket x minus x1, x1 is 7 plus value of b is 0. So 0 into y minus y1. So we write y minus y1, y1 is 8 plus c, value of c is 1, z minus z1, z1 is 6 is equal to 0. So first two terms are 0. So we get 0 plus 0 plus z minus 6 equal to 0. Therefore z is equal to 6 is the required Cartesian equation of the plane passing through the point 7, 8, 6 and parallel to the xy plane. See question number 8. The foot of perpendicular drawn from the origin to a plane is m of 1, 0, 0. Find the vector equation of the plane. So here we have to find the equation of plane passing through the point m of 1, 0, 0. So here normal vector is not given. So we have to find the normal vector because we know the equation of plane. The equation of plane passing through a of a bar and perpendicular to normal n bar is r bar dot n bar is equal to a bar dot n bar. So we require here n bar. So we calculate n bar. Now observe the diagram. This plane passing to the point m of 1, 0, 0. If we consider m bar as the position vector of m, let m of m bar be the position vector of point with respect to O. Now from this we write m bar is equal to I plus 0j plus 0k, that is equal to I. Now we have to find OM bar, which is normal. So we write here OM bar is equal to n bar is equal to. So from this we calculate the vector n bar as I cap, because 1 minus 0 is 1. So 1i, 0 minus 0 is 0j plus 0k. So vector OM is equal to I, which is n bar. Now we know the value of vector n, we know the value of m bar, which is position vector of that point, that means value of a bar. So we write here, therefore the required, we have to find vector equation of plane. Therefore the required vector equation of plane is r bar dot n bar is I cap is equal to, in place of a bar we have the position vector m bar, so we write m bar, or you can write directly value of m bar, or we write one step more. So r bar dot n bar is equal to m bar dot n bar. So we write r bar dot n bar, we calculate n bar as I cap is equal to m bar as I cap. Again this n bar as I cap dot I cap we get 1. So r bar dot I cap is equal to 1 is the required vector equation of the plane. The foot of perpendicular drawn from the origin to a plane is m of 1, 0, 0. Now say question number 9. Find the vector equation of the plane passing through the point A of minus 2, 7, 5 and parallel to the vectors 4i minus j plus 3k and I plus j plus k. Now we see one theorem. The vector equation of a plane passing through a point and parallel to two vectors. So we use that theorem for solving this problem. So first we write here the vector equation of plane passing through A of a bar and parallel to vectors B bar and C bar is R bar dot B bar cross C bar is equals to A bar dot B bar cross C bar. That means from this point we take value of A bar, that is position vector of this point A as A bar. So we get A bar equals to minus 2i plus 7j plus 5k, and these two vectors are parallel vectors. That means this vector is value of vector B and this value is value of vector C. So we write here, let A bar is equals to minus 2i plus 7j plus 5k be the position vector of point A, and B bar is equals to 4i minus j plus 3k. C bar is equals to this I plus j plus k, I plus j plus k. Now for this we have to find B bar cross C bar first. So we find B bar cross C bar. Therefore B bar cross C bar, we use the determinant. So in first row write ijk, then in second row coefficient of ijk of vector B, that is 4 minus 1 3, 4 minus 1 3, then ijk coefficient for vector C 1 1 1, 1 1 1. Now solve this determinant. So I in bracket minus 1 into 1 is minus 1, minus 1 into 3 is 3, minus j into 4 into 1 is 4, minus 1 into 3 is 3, 4 minus 3, plus k, 4 into 1 is 4, minus minus get plus, so 4 plus 1, so minus 1 minus 3 which is minus 4, minus 4i, 4 minus 3 is 1, so 1 into minus j, k, 4 plus 1 5, that is 5k. So this is value of vector B bar cross C bar, which is nothing but the normal to the required vector. Now then we find A bar dot B bar cross C bar. Therefore A bar dot B bar cross C bar is equals to, A bar is minus 2i plus 7j plus 5k dot B bar cross C bar is minus 4i minus 5j plus 5k. So from this we get minus plus 4 into 2 8, I dot I is 1, so we write 8, 7 into minus 1 we get minus 7, I dot I is 1, 5 into 5 that is 25, so we get here 26. So this is RHS. Now we have to substitute all this value for a required equation of plane. Therefore a required equation of plane is R bar dot B bar cross C bar is minus 4i minus 5j plus 5k is equals to 26. So in this way we find the vector equation of plane passing through the point A of minus 2 7 5 and parallel to the vectors 4i minus j plus 3k and I plus j plus k. Now say question number 10. Find the Cartesian equation of the plane, and given equation is R bar equals to 5i minus 2j minus 3k plus lambda into I plus j plus k plus mu into I minus 2j plus 3k. That means here lambda and mu are parameters given. That means we can say this is parametric form. So we have to reduce this equation into normal form, vector form first. Then from that we reduce that equation to Cartesian. So this is of the form R bar is equals to A bar plus lambda into B bar plus mu into C bar. That means this is equation of plane passing through A of A bar and parallel to vectors b bar and c bar. So we write vector equation of a plane passing through the point A of A bar and parallel to the vector B bar and C bar as, we write the vector equation of plane passing through A of A bar and parallel to vector B bar and C bar is R bar dot B bar cross C bar is equals to A bar dot B bar cross C bar. So we have the value of vector A, vector B, vector C. So first we find B bar cross C bar, then this A bar dot B bar cross C bar, and we reduce this equation then after to Cartesian form. So here A is equal to vector A is equal to 5i minus 2j minus 3k. Vector B bar is equal to I plus j plus k, and vector C equals to I minus 2j plus 3k. Now we first find B bar cross C bar. Therefore B bar cross C bar is equal to now in second row we write 1 1 1 1 1 1. In third row we write 1 minus 2 3 1 minus 2 3. Solve this determinant. So we get here I cap in bracket 1 into 3 is 3 minus minus get plus 2 into 1 is 2 plus here minus j cap in bracket 1 into 3 is 3 minus 1 into 1 is 1 3 minus 1 plus k cap in bracket 1 into minus 2 is minus 2 minus 1 into 1 is 1. So we write here 3 plus 2 5, so 5y. 3 minus 1 is 2, 2 into minus, so we get minus 2j, minus 2 minus 1 minus 3, so we get minus 3k. This is value of B bar cross C bar. Now we find the value of A bar dot B bar cross C bar. So we find here A bar dot B bar cross C bar is equals to A bar is 5i minus 2j minus 3k dot B bar cross C bar is 5i minus 2j minus 3k, which is equals to 5 5s are 25, I dot I is 1, minus minus get plus, 2 2s are 4, minus minus get plus, 3 is a 9, so we write here 9. So we get here 25 plus 4, that is 29, 29 plus 9, which is equals to 38. This is A bar dot B bar cross C bar. Now we substitute this value in this form. So we write, or you can denote this as equation number 1. Therefore, from equation 1, R bar dot B bar cross C bar, we calculate B bar cross C bar as 5i minus 2j minus 3k is equals to 38. Now this is vector form, we require the Cartesian form. So for Cartesian form, we write this R bar is equals to xi plus yj plus zk, because R is any point and we take coordinate of any point as xyz. Therefore xi plus yj plus zk dot 5i minus 2j minus 3k is equals to 38. So we get the Cartesian equation as 5x minus 2y minus 3z is equals to 38. This is required Cartesian equation of the plane for this given plane. Now see last question of this exercise, question number 11. Find the vector equation of the plane which makes intercept 1, 1, 1 on the coordinate axis. So for this we prove one theorem. The vector equation of a plane passing through three non-collinear points. If that three non-collinear points are capital A, capital B, capital C with position vector A bar, B bar, C bar, then the vector equation of plane passing through three non-collinear point is R bar dot AB bar cross AC bar is equals to A bar dot AB bar cross AC bar. So we use same concept here. Instead of A bar, B bar, C bar, we have provided the intercept as 1, 1, 1. So from this we calculate the value of vector A, vector B, vector C. So this, if we consider the plane intercept on x-axis, so the coordinate of this point A as 1, 0, 0, coordinate of this point B as 0, 1, 0, and coordinate of this point C as 0, 0, 1. So from this we write the position vector of point A, B and C. So we write here A bar is equals to I plus 0j plus 0k. B bar is equals to 0I plus 1j plus 0k. C bar is equals to 0I plus 0j plus 1k. Be the position vector of points capital A, capital B, capital C on, or we write be the position vector of point A, B, C, which are the intercept on the coordinate axis. So this A is intercept on x-axis, B is intercept on y-axis, and this C is intercept on z-axis. So first we calculate the value of vector AB, vector AC. So we write here, therefore vector AB. So vector AB can be written as position vector of B minus position vector of A. So we write here B minus A, B bar minus A bar. So 0 minus 1 we get minus 1. So minus I, 1 minus 0 we get 1. So 1j, 0 minus 0. So we get 0k. Then we have to find vector AC. Vector AC is equals to C bar minus A bar. So C bar minus A bar, which is 0 minus 1. So we get minus I, 0 minus 0 we get 0j, 1 minus 0 we get 1k. Now we know the value of vector AB, vector AC. So we calculate the cross product. So vector AB cross vector AC is equals to, so vector AB is minus 1, 1, 0. So we write minus 1, 1, 0. Vector AC minus 1, 0, 1. Minus 1, 0, 1. Plus, minus, plus. So calculate this value. I in bracket. 1 into 1 is 1. 0 into 0 is 0. So 1 minus 0 we get 1. Minus j in bracket. Here we get minus 1 into 0 is 0. 0 minus, 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 plus. So 1. Plus k in bracket, we get minus 1 into 0 as 0. So in this way we get the value 1i minus minus plus j, that is I plus j plus k. Now this is A bar cross vector AB cross vector AC. We require A bar dot vector AB cross AC. So we find A bar dot vector AB cross vector AC is equals to, now vector A is, we write 1i plus 0j plus 0k dot, this vector AB cross vector AC is I plus j plus k. So from this we get I dot I is 1, so 1 into 1 we get 1, 0, 0. So we get here A bar dot vector AB cross vector AC equals to 1. Now we have to substitute this value in this form. So we write here, therefore a required equation is r bar dot vector AB cross vector AC is I plus j plus k is equal to, right hand side we get 1. So this is vector equation of plane which makes intercept 1 1 1 on the coordinate axis.